Sarita.
Yeah, good evening, madam. This is Kodeshwara. Yeah, you can start, madam. Slowly, your strength pick up, madam. Just 15-20 minutes. Let me start change. మీ వాయిస్ వినిపిస్తుంది మేడం, స్క్రీన్ కూడా కనిపిస్తుంది. స్క్రీన్
Hello. 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 Hello.
Hello.
Hello. Yes. Hello. Hello.
Good evening,
Hello.
ma'am.
Good evening. Are you able to hear me? Yes.
Yes, ma'am.
Okay, I'll start.
మేడం డైరెక్ట్ పీపీటీ ఓపెన్ చేయండి, పీడిఎఫ్ ఓపెన్ చేయండి.
చేస్తాను. So spectroscope, you are able to hear now? Yes, you are able to hear now?
Yes, ma'am, it's clear.
So spectroscopy, మనం ఏదైనా, if you want to give the structure for any molecule, we are doing chemical reactions and spectroscopy. Nowadays the spectroscopy is very useful and it will not
మేడం
take
కొంచెం
much.
వాయిస్ మైక్రోఫోన్ దూరం ఉన్నట్టుంది మేడం, కొంచెం వాయిస్ లో వస్తుంది బాగా. కొంచెం మైక్రోఫోన్ దగ్గర ఉంటుంది అంటే.
Now is it clear? ఇప్పుడు బానే ఉందా? ఇప్పుడు బానే ఉందా?
మేడం వస్తుంది మేడం, పర్లేదు మేడం, ఇప్పుడు బాగా వస్తుంది.
బాగా వస్తుందా?
ఇప్పుడు వస్తుంది మేడం, బాగానే. ఓకే.
సో ఏదైనా ఎనీ మాలిక్యూల్ కి స్ట్రక్చర్ ఇవ్వాలంటే, సో ఐ విల్ ఎక్స్ప్లెయిన్ బోత్ ఇన్ తెలుగు అండ్ ఇంగ్లీష్. స్ట్రక్చర్ ఇవ్వాలంటే కెమికల్ రియాక్షన్స్ చేయొచ్చు, ఫిజికల్ స్పెక్ట్రోస్కోపీ కూడా యూజ్ చేయొచ్చు. సో రీసెంట్ గా స్పెక్ట్రోస్కోపిక్ మెథడ్ ఈస్ వెరీ యూస్ఫుల్. So based on spectroscopy we can give the structure of any molecule. So especially so many absorption spectra are there, IR, UV, NMR, all those. So our spectra anni how we are getting by passing electromagnetic radiation through the molecule. But mass spectrum gives directly the mass molecular weight of the compound. Mass spectra nunchi manaku direct ga molecular weight vastundi. కానీ దీన్ని స్పెక్ట్రోస్కోపీ అనరు, దీన్ని మాస్ స్పెక్ట్రోమెట్రీ అంటారు. దెర్ ఈస్ సమ్ మిస్టేక్. ఇట్ ఈస్ నాట్ స్పెక్ట్రోస్కోపీ హియర్, ఇట్ ఈస్ నాట్ స్పెక్ట్రోస్కోపీ. మాస్ స్పెక్ట్రమ్ ఈస్ కాల్డ్ యాజ్ మాస్ స్పెక్ట్రోమెట్రీ. వై? బికాస్ ఇట్ ఈస్ నాట్ అబ్జార్బింగ్ ఎనీ ఎనర్జీ ఫ్రమ్ ఎలక్ట్రోమాగ్నెటిక్ రేడియేషన్. అయితే మాస్ స్పెక్ట్రమ్, వాట్ ఈస్ ద యూజ్ ఆఫ్ మాస్ స్పెక్ట్రమ్? ఇట్ డైరెక్ట్లీ గివ్స్ ది మాలిక్యులర్ వెయిట్ ఆఫ్ ది కాంపౌండ్. అండ్ ఎలక్ట్రోమాగ్నెటిక్ రేడియేషన్ ని పంపించట్లేదు మనం. IR, UV, NMR వాటన్నిట్లలో మనం ఏం చేస్తామంటే మాలిక్యూల్ ద్వారా ఎలక్ట్రోమాగ్నెటిక్ రేడియేషన్ ని పంపిస్తాం. వీఆర్ పాసింగ్ ది ఎలక్ట్రోమాగ్నెటిక్ రేడియేషన్ త్రూ ది శాంపుల్ ఇన్ IR, UV, NMR, etc. But in mass spectrum we are not passing any electromagnetic radiation. Then how you are getting mass spectrum means the molecule is bombarded. Ante instead of electromagnetic radiation we are passing the energy from the electron beam. Electron beam ante entante pool of electrons. If you put pool of electrons, that is called electron beam. So the molecule is taken and bombarded with an electron beam of 70 electron volts. Electron beam ante em ledu, electron pool of electrons. If you put pool of electrons, the energy will be 70 electron volts. So that electron beam molecule is bombarded with that electron beam. So when the molecule is bombarded with electron beam, the molecule undergoes loss of one electron. I'll show here how we are getting. So what is the use of mass spectrum? It directly gives the molecular weight of the compound. So here you see this. This is the molecule. So molecule always contains even number of electrons. This molecule, for example, methane, you take methane and bombarded with an electron beam of 70 electron volts. So this energy is very high. Whereas ionization potential of organic molecules is only 7 to 15 electron volts. Ionization potential ante enti molecule lonchi oka electron ni తీసేయాలంటే కావాల్సిన ఎనర్జీ. సో మాలిక్యూల్ నుంచి ఒక ఎలక్ట్రాన్ తీసేయాలంటే ఓన్లీ 7 to 15 electron volts is sufficient. కానీ మనం ఇక్కడ ఎంత ఎనర్జీని యూజ్ చేస్తున్నాం? 70 electron volts. So the molecule is bombarded with 70 electron volts. It is more than the ionization potential of organic molecules. So when the molecule is bombarded with 70 electron volts, what happens? The molecule undergoes loss of one electron. Here you are having even number of electrons. So from even number of electrons, it is losing one electron. And ekkadaithe electron poyindo, akkada you are putting positive charge. Because, for example, you are having methane. Here I am giving example. So methyl chloride. So methyl chloride, methyl means 15, chlorine means 35. So the molecule is having 50 electrons, 50 protons. Electrons, number of electrons is equivalent to number of protons. So take methyl chloride, bombard with 70 electron volts. What happens? From any bond, from CH bond or CCl bond, from any one bond, one electron is lost. So one electron is lost means the molecular ion is having one electron less than the molecule, 49 electrons and 50 protons. So where the electron is lost, we are putting positive charge. Actually, it should have 2 electrons, but 1 electron is lost. At that place, we are putting positive charge. This is called molecular ion. Molecular ion. So this is the molecule. For molecule, always we are writing molecular weight 50. And molecular ion also, M by Z means mass by charge. So mass is equal. In both the cases, mass is equal. Here also 50, here also 50. But charge is 1 here. There is no charge here. So M by Z is 50. So the M by Z of molecular ion is directly equivalent to molecular weight. Here you can't write molecular this M by Z because there is no charge at all. Take the molecule, bombard with the electron impact of 70 electron volts, and 1 electron is lost from any bond, either from CCl bond or CH bond. From any one bond, 1 electron is lost. A bond is formed by combination of 2 electrons.
మేడం పీపీటీ పీడిఎఫ్ ఫైల్ ఓపెన్ చేయండి మాస్క్.
కాదు, ఇది సైన్ ఇన్ అని వస్తుంది. జాయిన్ మీటింగ్ సైన్ ఇన్ అని వస్తుంది.
అదే మన అది ఉంది కదా ఐడి అని, మీరు ఆల్రెడీ జాయిన్ అయిపోయారు.
జాయిన్ అయ్యాను, మళ్ళీ ఎందుకు వస్తుంది? అది పోవట్లేదు.
అది ఇది మినిమైజ్ చేయండి. మినిమైజ్ చేయండి. మాస్ స్పెక్ట్రా ఫైల్ ఎక్కడ ఉందో చూడండి, అది ఎక్కడ, అది ఓపెన్ చేస్తే సరిపోతుంది. మాస్ది పీడిఎఫ్ ఉంటుంది కదా మేడం, అది ఓపెన్ చేస్తే రీస్టోర్ అనండి. బ్లూ కలర్ రీస్టోర్ ని క్లిక్ చేయండి.
ఎక్కడ ఉంది రీస్టోర్?
బ్లూ కార్నర్ మీద ఇటు
ఇదా? నాకేమో ఇవన్నీ
అదే ఆ వాట్సాప్ ఓపెన్ అయింది, దాంట్లో ఉండొచ్చు కదా మేడం బహుశా ఫైల్.
ఏది?
పీడిఎఫ్ ఫైల్ ఎక్కడ ఉంది?
దీంట్లో ఉంది. ఏది? డౌన్లోడ్స్ లో ఉంది.
డౌన్లోడ్స్ ఓపెన్ చేయండి, అక్కడికి వెళ్ళి. ఎస్, అక్కడి నుంచి ఓపెన్ ఓపెన్ చేసేసి ఫైల్ ఎక్కడ ఉంది చూసి ఓపెన్ చేసేసి వచ్చేసి వస్తుంది కొంచెం వస్తుంది మేడం, ఏం కాదు. అది ఏమైందంటే వచ్చేసింది చూడు, మళ్ళీ 2 times స్టార్ట్ ప్రాబ్లం అది వచ్చేసింది మేడం, కనిపిస్తుంది. ఇక్కడ మన ఆర్గనైజ్ పేజ్ దగ్గర యారో ఉంది కదా, యారో మీద క్లిక్ చేయండి, వైడ్గా వస్తుంది స్క్రీన్. ఇక్కడ యారో బటన్ ఉంది కదా, స్క్రోల్ బార్ మీద అక్కడ అది స్క్రోల్ బార్ పక్కన ఇక్కడ యారో ఉంటుంది, అది కాదు మేడం. అట్లా ఏం కాదు, కంటిన్యూ చేయండి.
So just once in a while, once again, I'll repeat. The structure of any molecule can be given by 2 methods, chemical methods and physical methods. Physical methods include spectroscopy. There are so many spectra are there, like IR, NMR, mass, UV, so many spectra. All these are absorption spectra, but mass is not an absorption spectrum, because mass we are not getting by passing electromagnetic radiation. And then how you are getting mass spectrum means you are taking the molecule and bombarding the molecule with the electron beam of 70 electron volts. So what do you mean by electron beam means? It is nothing but pool of electrons. So take the molecule, molecule is always having even number of electrons, and you bombard with 70 electron volts. The energy is very high. So therefore, when the molecule is passing through the electron beam, the electron beam takes 1 electron from the molecule. So ekkadi nunchi aithe electron poyindo akkada positive charge vastundi. Actually, methyl chloride, it is having 50 electrons, 15 protons, but after passing through electron beam, it is having only 49 electrons and 50 protons. The charge of proton is positive charge. Therefore, we are putting plus. So plus dot, it is called molecular ion. So now you are able to write M by Z. M is nothing but mass, Z is charge. So M by Z is equivalent to 50. So M by Z of molecular ion is directly equivalent to molecular weight of the compound. Nothing, molecular weight is due to protons. Proton number is same. Here also 50, here also 50. So therefore, there is no change in protons. Only 1 electron is lost. And we are getting charge. Therefore, M by Z is 50. M by Z of molecular ion. This is called molecular ion. How we are getting molecular ion? By loss of 1 electron from the molecule. So molecular ion always has the mass equivalent to molecular weight. So M by Z is equivalent to 50. This is the molecular weight of the compound. And this is called molecular ion or parent ion. So this parent ion is associated with more energy. Therefore, it undergoes loss of neutral species. For example, Cl dot. It undergoes loss of Cl dot. You are getting CH3 plus. This is called daughter ion. And this is the molecular ion. This is the daughter ion. All these ions are recorded in the mass spectrum. So here you see this molecular ion results. Molecular ion from the molecule. Molecular ion results from the molecule by the loss of an electron from the molecule and has the same mass as that of the molecule. So molecule ki molecular ion ki same mass untundi. Only what is the difference? 1 electron is less in molecular ion than the molecule. A molecule always has even number of electrons, whereas the molecular ion has number of electrons, odd number of electrons or unpaired electrons having positive charge. Therefore, it is called as cation radical. ఒక పాజిటివ్ చార్జ్ ఉంటుంది, ఒక ఎలక్ట్రాన్ ఉంటుంది కాబట్టి దాన్ని క్యాటయాన్ రాడికల్ అంటారు. సో వాట్ ఈస్ మాస్ స్పెక్ట్రమ్? ఇట్ ఈస్ నథింగ్ బట్ M by Z ratio of cationic species. Only cationic species are recorded in the mass spectrum. So M by Z of cationic species, ratio of M by Z of cationic species versus relative abundance. RA means relative abundance. Relative abundance is nothing but stabilities of the carbocations. For example, tertiary butyl carbocation. So tertiary butyl carbocation is tertiary carbocation. So if it is more stable. So therefore, this peak intensity will be very high. That is called relative abundance. Relative abundance is associated with the stabilities of the carbocations. If the carbocation formed is more stable, the peak height is more. If the carbocation is less stable, peak height will be less. So that is called relative abundance. And M by Z means mass by charge. Mass by charge of various cationic species. For example, here we are taking methyl chloride. Molecular ion. Here we are taking methyl chloride. See this. This is the molecule and this is the molecular ion. M by Z of molecular ion. 50 by 1 is equal to 50. And it is undergoing loss of Cl dot. It is giving rise to methyl carbocation. So two cationic species are there. One is M by Z of 50 and one is CH3. So this is daughter ion, this is the molecular ion. Like this, all the ions are recorded in the mass spectrum. Only cationic species are recorded in the mass spectrum. No anions, no radicals. Here, the basic principle of mass spectrometry is to generate ions from either inorganic or organic compounds by any suitable method to separate these ions by this mass to charge ratio. Mass spectrometry is not an absorption spectrum because it is not absorbing any electromagnetic radiation. And once the sample is, so in NMR and UV, you are putting the sample in the spectrometer and you are recording the spectrum. Spectrum record చేసిన తర్వాత sample ని మనం మళ్ళీ బయటికి తీసుకోవచ్చు. Recovered sample can be taken. But here in the mass spectrum, once the sample is introduced to the mass spectrometer, it cannot be recovered. ఒకసారి spectrometer లో mass compound పెట్టామంటే it is not possible to recover back the remaining sample. అదే NMR లో అయితే after recording the spectrum, the remaining sample we can recover back. Here it is not possible. So this spectrum is used to determine the molecular weight of the substances. Mass spectrum direct ga molecular weight of the compounds istundi. So in mass spectrum, small quantity of the substance is needed. Mass spectrum record cheyalante very little sample. You see this 10 to the power minus 6 grams is enough to record the mass spectrum. ఇంకా కొన్ని natural products లో మనకి చాలా తక్కువ వస్తుంది కాంపౌండ్. అలాంటప్పుడు even 10 to the power minus 12 grams is also sufficient to record the spectrum. So this is the mass spectrum. So what is the mass spectrum? It is a plot of M by Z ratio values of various cationic species versus relative abundance. M by Z of various cationic. You remember, only the cationic species are recorded in the mass spectrum. So M by Z ratio of various cationic species versus relative abundance. Relative abundance is nothing but stabilities of the carbocations. If the carbocation is more stable, peak height will be more. If carbocation is less stable, peak height will be less. That is the relative abundance. So very little sample is enough to record this mass spectrum. And once the sample is introduced in the mass spectrum, it is not possible to recover back the sample. And it is not the absorption spectrum. Why it is not absorption spectrum? Because it is not absorbing any energy from the electromagnetic radiation. Then how you are getting mass spectrum? Mass spectrum is obtained by bombardment of the organic molecule with an electron beam of 70 electron volts. Now you see this. This is the molecule. Molecule is always having even number of electrons. You are bombarding the molecule with an electron beam of 70 electron volts. The energy is very high. So when the molecule is passing through this energy, this electron beam takes one electron from the molecule. So positive and here you are having two electrons means it is not the meaning of only two. Even number of electrons. Molecule is always having even number of electrons. When it is passed through the electron beam, it is having one positive charge. So this is called M plus dot or P plus dot. M plus dot means molecular ion. P plus dot means parent ion. This you remember M by Z of M plus dot is directly equivalent to molecular weight. We have seen in the methyl chloride 50-50. So this we are able to write M by Z for molecular ion, but we are unable to write M by Z for molecule because there is no charge at all. So once you pass through the electron beam, you are getting M by Z. This is the M plus dot or P plus dot, molecular ion or parent ion. So M by Z of molecular ion or parent ion is directly equivalent to molecular weight of the compound. So here, same example they have given. Methyl chloride 50, electron impact of 70 electron volts, you are getting M plus dot or P plus dot. Why you are calling P plus dot or M plus dot? Because after loss of electron at that place, you are having positive charge. So when this molecular ion undergoes loss of Cl dot, you are getting methyl carbocation. Here you see M by Z is directly equivalent to molecular weight of the compound. So mass spectrum is, this is the plot. Mass spectrum is presentation of M by Z mass by charge, M by Z ratio of various values of various cationic species and their related relative abundance. Relative abundance. RA, relative abundance means stabilities of the carbocations. This is the mass spectrum. It is a plot of M by Z ratio values of various cationic species versus their relative abundance. Relative abundance is nothing but stabilities of the carbocations. So M is equal to mass of the ion, Z is equal to charge of the ion. Relative abundance is associated with the stabilities of the carbocations. Now, explain the types of fragments, odd and even electron containing neutral and charged species, even electron rule. So, you see this. Molecular ion is associated with more energy, therefore, it undergoes fragmentation and gives daughter ions. So, you are taking the molecule. First, you are taking the molecule, you are bombarding with 70 electron volts, you are getting the molecular ion. This is the molecular ion. So M by Z of molecular ion is directly equivalent to molecular weight of the compound. So molecular ion is unstable because it is associated with more energy. Therefore, it immediately undergoes fragmentation. How many types of fragmentations are possible? You see this. M plus dot, it may undergo loss of OE dot. OE dot means odd electron containing neutral species. There are two types of neutral species in mass spectrum. Odd electron containing neutral species, even electron containing neutral species. Odd electron containing neutral species means here already we have seen that Cl minus, Cl dot. So here Cl dot means it is having, undergoing loss with one electron. This is called OE dot, odd electron containing neutral species. Even electron containing neutral species means loss of H2, loss of H2O, loss of CO, loss of CO2, loss of C2H4, like that. Those are called EE, loss of neutral, even electron containing neutral species. And loss of odd electron containing species means OE dot. This is called OE dot. So, yes, sir. The molecular ion may undergoes loss of OE dot. From this molecular ion, if one dot is lost, means what is the resulting daughter ion? Radical is lost. You are getting pure carbocation, EE plus. EE plus means even electron containing carbocation, pure carbocation. So therefore, molecular ion may undergo loss of OE dot. OE dot means loss of Cl dot. You are getting CH3 plus. That CH3 plus, it is called as EE plus. EE plus means pure carbocation, even electron containing carbocation. Or it may undergo loss of EE. EE means neutral species. I already told you what are neutral molecules: H2, H2O, CO, CO2, C2H4, like that. So if the molecular ion undergoes loss of EE, again you are getting OE plus dot, odd electron containing cationic species. So therefore, from the molecular ion, how many types of daughter ions are formed? Two types of daughter ions are formed. This is EE plus. How we are getting EE plus from M plus dot? By loss of OE dot. OE dot means odd electron containing neutral species. And from M plus dot, how we are getting OE plus dot? OE plus dot you are getting by loss of EE. EE is nothing but neutral species. I gave some examples. You go through that. I'll explain. So in the mass spectrum, there are two types of neutral species. So I'll explain here. In the mass spectrum, there are two types of neutral species. OE dot, odd electron containing neutral species. That means H dot, Cl dot, R dot, etc. And second type of neutral species are EE, even electron containing neutral species. For example, H2, H2O, CO, CO2, etc. Depending upon the depending upon the types of neutral species last, daughter ions are of two types. గుర్తుపెట్టుకోండి, ఫస్ట్ మాలిక్యూల్ నుంచి మాలిక్యులర్ ion ఫామ్ అవుతుంది. How the molecular ion is formed? When the molecule undergoes loss of an electron, you are getting M plus dot or P plus dot. That is called molecular ion. So molecular ion is associated with more energy. Therefore, it undergoes fragmentation, gives rise to two types of daughter ions, E plus and OE plus dot. How these two types of daughter ions are formed? By loss of neutral species. So neutral species in the mass spectrum, there are two types. So you see this. First molecule is giving molecular ion. So M by Z of molecular ion is directly equivalent to molecular weight. So this molecular ion undergoes loss of two types of neutral species. There are two types of neutral species. What are the two types of neutral species? OE dot and EE. Suppose the molecular ion undergoes loss of OE dot, odd electron containing neutral species, you will be getting pure carbocation, EE plus. Suppose if the molecular ion undergoes loss of neutral molecule, you are getting OE plus dot, odd electron containing cationic species. So in the mass spectrum, there are two types of neutral species. OE dot, odd electron containing, this you remember. Two types of daughter ions, two types of smaller neutral species. Neutral species are two types. What are the two types of neutral species? OE dot. OE dot means odd electron containing neutral species, H dot, Cl dot, R dot, etc. And EE means even electron containing neutral species, H2, H2O, CO, CO2, etc. So depending upon the type of neutral species lost, daughter ions are of two types. If the loss of the neutral species is free radical, OE dot, then a pure carbocation is formed. If the loss of neutral species is a neutral molecule, then a cation radical is formed. So this is the even electron rule. So you see this here. This is the molecule. This is a molecule. Electron impact of 70 electron volts. Molecule is undergoing loss of an electron, giving rise to M plus dot. Where the electron is lost, we are putting positive charge. So this is nothing but molecular ion or parent ion. This molecular ion is associated with more energy. Therefore, immediately it undergoes fragmentation. And it is giving rise to two types of daughter ions. The molecular ion, when it undergoes OE dot, odd electron containing neutral species, it is giving rise to pure carbocation. And if the molecular ion undergoes loss of neutral molecule, EE, it is giving rise to OE plus dot, odd electron containing cationic species. These two are the daughter ions. We are putting capital letters. This is the molecular ion. These two are the daughter ions. Again, this daughter ion undergoes two types of fragmentations. EE plus, it may undergo loss of again EE, you are getting EE plus, small EE plus. This is the molecule, this is the molecular ion. These two are the daughter ions, and from daughter ions, you are getting smaller ions. So EE plus may undergo loss of EE, we are getting again EE plus. This is smaller ion. And EE plus may undergo loss of OE dot, it is giving rise to OE plus dot. Similarly, this OE plus dot, it may undergo loss of OE dot, it is giving rise to EE plus. And OE plus dot, it may undergo loss of EE, it is giving rise to again OE plus dot. So like this, four different types of, this is the molecular ion, these two are daughter ions, and these four are smaller ions. So all these ions are recorded in the mass spectrum. The fragmentation of EE plus and formation of OE plus dot, and OE dot is least probable thermodynamically in view of high energy content of the product. So here you see the stabilities of the carbocations. Pure carbocation is always stable than cation radical. So EE plus is more stable than OE plus dot. Similarly, small EE plus is more stable than small OE plus dot. And stabilities of the neutral species. Neutral molecule EE is more stable than OE plus dot. So on the basis of this, you see this. Out of 4. So either neutral species or cationic species. Either ఒకటి స్టేబుల్ అయి ఉంటేనే ఆ ఫ్రాగ్మెంటేషన్ అవుతుంది. So this is the molecular ion. Molecular ion is undergoing loss of OE dot. You remember the methyl chloride. So methyl chloride is undergoing loss of Cl dot. OE dot. Cl dot means OE dot. It is giving rise to E plus means methyl carbocation. So M plus dot is undergoing loss of OE dot. It is giving rise to E plus. E plus also undergoes sometimes fragmentation. In the case of methyl carbocation, it will not undergo further fragmentation. Suppose if any other fragmentation is there, bigger, larger one, E plus, again it undergoes fragmentation by loss of E, giving rise to E plus, and by loss of OE dot, it is giving rise to OE plus dot. అయితే దీంట్లో ఏంటంటే ఎయిదర్ న్యూట్రల్ అన్నా క్యాటయాన్ అన్నా ఏదో ఒకటి స్టెబిలిటీ అయితేనే ఆ ఫ్రాగ్మెంటేషన్ అవుతుంది. సో దీంట్లో న్యూట్రల్ స్పీషియస్ స్టేబులే, cation radical is also stable. Both are stable. Therefore, this fragmentation is possible. And here, OE plus dot is less stable, neutral species is less stable, and cation radical is also less stable. So therefore, this type of fragmentation is least probable. It will not take place. And here you see OE plus dot, it is undergoing loss of OE dot, EE plus. ఇది less stable గానీ ఇది more stable. So therefore, ఏదన్నా ఒకటి stable అయి ఉంటేనే అవుతుంది. So OE plus dot is undergoing loss of OE dot, it is giving rise to EE plus. So ikkada cation is more stable, therefore this fragmentation is taking place. And what is the fourth one? OE plus dot is undergoing loss of EE, it is giving rise to OE plus dot. దీంట్లో cation radical is less stable, but neutral species is stable, therefore it undergoes fragmentation. So therefore, out of 4 fragmentations, this is possible, this is possible, and the first one is possible. But this second one is not possible because OE dot is also less stable, OE plus dot is also less stable. So this is called even electron rule. What the even electron rule says, the fragmentation of EE plus and formation of OE plus dot and OE dot. The second one, fragmentation of EE plus, formation of OE dot and OE plus dot is least probable thermodynamically in view of high energy content of the product mixture. Both are associated. Neutral species is high energetic and cation is also high energetic. Therefore, that fragmentation is not possible. Other 3 are possible. Only second one is not possible. And this is the even electron rule. And next, nitrogen rule. So, what is the nitrogen rule says means a molecular ion with a 0 or mass spectrum బట్టి మనము మాస్ స్పెక్ట్రమ్ చూసి మనం నైట్రోజన్ మాలిక్యూల్ ఉందా లేదా అని ఈజీగా తెలుసుకోవచ్చు. ఎట్లా అంటే ఒకవేళ నైట్రోజన్ ఉందనుకోండి, సపోజ్ ఎనిలీన్ ఉందనుకోండి, ఎనిలీన్ లో ఒక నైట్రోజన్ ఉంది. సో మాలిక్యులర్ వెయిట్ ఈస్ 93. అండ్ పిరిడిన్ ఉందనుకోండి, పిరిడిన్ లో కూడా ఒక నైట్రోజన్ ఉంటుంది, మాలిక్యులర్ వెయిట్ ఈస్ 79. సో మనం ఏంటంటే ఆడ్ మాస్ ఆల్వేస్ ఇండికేట్స్ ది ప్రెసెన్స్ ఆఫ్ నైట్రోజన్. ఒకటి కానీ ఆడ్ నెంబర్ ఆఫ్ నైట్రోజన్స్, ఇఫ్ దెర్ ఆర్ ఆడ్ నెంబర్ ఆఫ్ నైట్రోజన్స్, మాస్ is also odd. So that is called nitrogen rule. So with the help of mass spectrum, we are able to identify the presence of nitrogen. How it is possible? Nitrogen, presence of nitrogen, molecular weight is odd. So a molecular ion with a 0 or even number of nitrogens will always has even mass. ఒకవేళ even number of nitrogens ఉంటే molecular weight is also even. You see this methanol there are 0 number of nitrogens. So number of nitrogens are 0, mass should be even, and molecular weight is 32. And acetic acid, number of nitrogens is 0, mass should be even, molecular weight is 60. That means molecule with 0 or even number of nitrogens will always have even mass. ఇక్కడ చూడండి, paranitro-aniline, number of nitrogens 2, even, and mass should be even, molecular weight is 138. Kabatti any molecule with 0 or even number of nitrogens will always have even mass. And second rule ఏంటంటే nitrogen rule లో second point ఏంటంటే molecular ion with odd number of nitrogens will always have odd mass. ఒకవేళ odd number of nitrogens ఉన్నాయనుకోండి molecule లో, mass is also odd. So how? If you see this methyl cyanide, or this is also called acetonitrile. Methyl cyanide అనొచ్చు, acetonitrile అనొచ్చు. So number of nitrogens ఎన్ని ఉన్నాయి? 1 ఉంది, odd. So number of nitrogens is 1, odd. Therefore, mass should be odd. Molecular weight is 41, odd mass. అంటే ఇట్లా 41 కానీ 93 కానీ 79 కానీ ఉందనుకోండి, immediately without thinking you can say that nitrogen is present in the molecule. So methyl cyanide, acetonitrile, number of nitrogens is 1. Mass should be odd. So molecular weight is 41. And you see this here, aniline, only 1 nitrogen. So number of nitrogens is 1, mass should be odd. Molecular weight is 93. Similarly, you take pyridine. Pyridine is also only 1 nitrogen. Molecular weight is 79. And this one, trinitrobenzene. Number of nitrogens are 3. Mass should be odd. The molecular weight is 213. కాబట్టి మీకు ఎక్కడైనా molecular weight odd ఉంది అనగానే immediately you can say that nitrogen is present in the molecule. So this is called nitrogen rule. And the third point in nitrogen rule is, by fission of one bond, molecular ion of even mass will give daughter ion of odd mass. అంటే మాలిక్యులర్ అయాన్ ఒకవేళ ఆడ్ మాస్ ఉందనుకోండి, ఒక బాండ్ క్లీవ్ అవుతే డాటర్ అయాన్ ఆఫ్ ఈవెన్ మాస్ ఇస్తుంది. అట్లాగే మాలిక్యులర్ అయాన్ ఈవెన్ మాస్ ఉందనుకోండి, ఒక క్లీవ్ అవుతే డాటర్ అయాన్ ఆఫ్ ఆడ్ మాస్. సో బై ఫిషన్ ఆఫ్ వన్ బాండ్, మాలిక్యులర్ అయాన్ ఆఫ్ ఈవెన్ మాస్ విల్ గివ్ డాటర్ అయాన్ ఆఫ్ ఆడ్ మాస్, and a molecular ion of odd mass will give a daughter ion of even mass, provided nitrogens present, if any, should be retained in the daughter ion. I'll explain this. This is pyridine. Pyridine means molecular odd number of nitrogens. Molecular weight is 79, odd mass. So you are bombarding with 70 electron volts, you are getting molecular ion. 1 electron is lost, and at that place you are putting positive charge. This is called M plus dot or P plus dot. M by Z is 79. So suppose if it is undergoing loss of H dot, ఇక్కడ నుంచి ఒక H dot పోయింది అనుకోండి, OE dot పోతే ఇక్కడ ఏమవుతుంది, ఒక H dot పోతే ఇక్కడ C కి H కి మధ్యలో 2 electrons ఉంటాయి. ఒక ఎలక్ట్రాన్ పోయింది అనుకోండి, ఒక ఎలక్ట్రాన్ ఉంటుంది. So this and this will form a bond. You are putting positive charge, E plus. So this is 79. By cleavage of one bond, it is giving daughter ion of odd mass, molecular ion of odd mass. By cleavage of one bond, it is giving daughter ion of even mass. అంటే మాలిక్యులర్ ion ఆడ్ మాస్ ఉంటే, ఒక బాండ్ క్లీవ్ అవుతే, ఏదో ఒక న్యూట్రల్ స్పీషియస్ పోతే వచ్చే డాటర్ ion కి ఈవెన్ మాస్ ఉంటుంది. ఆర్ డాటర్ ion of even mass, when it undergoes cleavage of one bond, it gives daughter ion of odd mass. That is called nitrogen rule. Here they have given the table. So number of nitrogens are odd. అంటే pyridine అనుకోండి. Number of nitrogens are odd. M by Z is also odd. Number of nitrogens are odd. M by Z is also odd, means molecular ion. M by Z is number of nitrogens are odd. M by Z is even, means daughter ion. And number of nitrogens are even. M by Z is also even, means molecular ion. And number of nitrogens are even, M by Z is odd, then it is daughter ion. This is called nitrogen rule. Explain the isotopic effect with one example. దీంట్లో ఏంటంటే మనం మాస్ తోని నైట్రోజన్ ఉందా లేదా తెలుసుకుంటాం. ఎట్లా తెలుసుకుంటాము? మాలిక్యులర్ వెయిట్ ఒకవేళ ఆడ్ అయితే కనుక డెఫినెట్ గా నైట్రోజన్ ఉందని తెలుస్తుంది. ఈవెన్ ఉంటే కొంచెం మనం చేయాలనుకోండి, వర్క్ చేయాలి. కానీ ఆడ్ ఉంటే మాత్రం డెఫినెట్ గా ఆడ్ మాలిక్యులర్ వెయిట్ తోని మనకు నైట్రోజన్స్ ఉన్నాయని తెలుస్తుంది. తర్వాత మాస్ స్పెక్ట్రాతోని మనం క్లోరిన్ ఉందా లేదా తెలుసుకోవచ్చు, బ్రోమిన్ ఉందా లేదా తెలుసుకోవచ్చు, సల్ఫర్ ఉందా లేదా తెలుసుకోవచ్చు మాలిక్యూల్ లో. సో దీన్ని ఏమంటారంటే ఐసోటోపిక్ ఎఫెక్ట్ అంటారు. అంటే చెప్తాను, ఐ విల్ ఎక్స్ప్లెయిన్. there are many elements which occur as isotopes in nature. The natural abundance of these isotopes is unequal in ratio. One of the isotope is more abundant than the other. The most natural abundant isotope is known as lighter isotope, and the less naturally abundant isotope is known as heavier isotope. ప్రతి అంటే కొన్ని ఎలిమెంట్స్ కి ఐసోటోప్స్ ఉంటాయి. నార్మల్ ఐసోటోప్ ఏమో లైట్, హెవీ ఐసోటోప్ ఏమో naturally abundant isotope is known as heavier isotope. The radical cation formed from lighter isotope is known as molecular ion. ఎప్పుడైనా సరే మాలిక్యులర్ వెయిట్ డిటర్మిన్ చేసేటప్పుడు నార్మల్ ఐసోటోప్ నే పెడతారు. చూడండి ఇక్కడ నేను చెప్తాను. The isotopic peaks gives the information about the presence of chlorine, bromine, iodine, and also gives information about the number of carbons. Isotopic peaks. Isotopic peaks. So tomorrow I will give that notes. It is not here. Just tomorrow I'll copy down. First I'll explain this McLaughlin rearrangement. This is one of the important rearrangement in mass spectrum. That isotopic peaks also, it is very important. So tomorrow I'll give. First you listen McLaughlin rearrangement. What is McLaughlin rearrangement means? You see this. This is the double bond, olefinic carbon, sp2 carbon. This carbon, sp2. So attached one alpha, this is beta, this is gamma. So for McLaughlin rearrangement, gamma hydrogen is essential. Presence of gamma hydrogen. Gamma means with respect to double bond, the next carbon is alpha, this is beta, this is gamma. So if there is gamma hydrogen, then only the molecule undergoes McLaughlin rearrangement. So maybe this is aromatic or aliphatic, no problem, but double bond should be there. So to the doubly bonded carbon, attached carbon is alpha, this is beta, this is gamma. So what the McLaughlin rearrangement says is, under an electron impact, elimination of a neutral molecule from a suitable unsaturated system through a 6-member transition state involving gamma hydrogen transfer is called McLaughlin rearrangement. So what is essential for McLaughlin rearrangement? Presence of suitable unsaturated system is essential, and presence of gamma hydrogen is also essential. So McLaughlin rearrangement, this is one of the important rearrangement in mass spectrometry. So under an electron impact, if you are passing electron beam of 70 electron volts, elimination of a neutral molecule from a suitable unsaturated system. The molecule should contain suitable unsaturated system involving 6-member transition state. Gamma hydrogen transfer is called McLaughlin rearrangement. So McLaughlin rearrangement undergoes in alkenes, aldehydes, ketones, carboxylic acids, esters, and amides. In all these compounds, McLaughlin rearrangement is possible, provided the molecule contains the gamma hydrogen. Gamma hydrogen untene ee molecule annitlo McLaughlin rearrangement avutadi. Aldehydes lo avutadi, alkenes lo avutadi, ketones lo avutadi, carboxylic acids lo avutadi, esters lo avutadi, amides lo avutadi. So provided the molecule should contain suitable unsaturated system and gamma hydrogen. If one compound is having gamma hydrogen and the other compound is not having gamma hydrogen, means we can differentiate these two compounds by mass spectrum. The molecule which is having gamma hydrogen undergoes McLafferty. The first one which have gamma hydrogen has strong peak due to McLafferty rearrangement. Other one will not have no such peaks. So best example they have given this N-propyl benzene. So నేను చేస్తా అయిపోయింది అయిపోతుంది. So this is suitable benzene. This is suitable unsaturated system. This is alpha hydrogen. This is alpha carbon. Hydrogens attached are alpha hydrogens. This is beta carbon and gamma carbon. So it is having gamma hydrogen. Therefore, it undergoes McLafferty rearrangement. So how it undergoes? N-propyl benzene, molecular weight is 120. Electron impact of 70 electron volts. It is giving rise to molecular ion. So molecular ion is represented like this, overall plus dot. So now what happens? This alpha, beta, gamma. So this gamma hydrogen, gamma carbon, gamma hydrogen bond is broken. This is broken. This H dot will come and attack on this. And this pi bond, it comes here, and this comes here. So this CH2 double bond CH2 is eliminated as neutral molecule, and this H dot will go and attack on this. So what you are going to get? Loss of CH2 double bond CH2. Ethylene is last. Ethylene is last. So here McLafferty rearrangement. Ethylene is last, and this H dot will go and attack on the this carbon. So double bond is now shifted here. So there is no double bond between these two carbons. Double bond is shifted here, and this H dot gamma hydrogen is attacking on this. And what is last here? Ethylene is last, and M by Z is 92. Here M by Z is 120. Loss of CH2, you are getting M by Z 92. And here, now 3 types of cleavages it undergoes. Alpha cleavage. Alpha cleavage means this is olefin, this is sp2 carbon. This is called alpha bond. So if this bond is broken means, what is last? CH3, CH2, CH2. Propyl radical is last. You are getting phenyl carbocation. So this is called alpha cleavage, phenylic cleavage. You are getting phenyl carbocation. And beta cleavage means, and this bond, alpha beta bond is gets cleaved. And what is last? Ethyl radical is last. CH3, CH2 is last. And you are getting benzyl carbocation. This is alpha cleavage means phenyl carbocation. Propyl radical is last. And beta cleavage means this ethyl radical is last. And you are getting benzyl carbocation. M by Z is 91. And McLafferty rearrangement means this H dot migrates to this, and double bond is shifted here. This ethylene is last. And you are getting M by Z 92. This is the peak due to McLafferty rearrangement, and 92. M by Z 92 is due to McLafferty rearrangement. And this peak height will be more because it is stabilized by resonance. So out of these 3 peaks, this peak height will be more. M by Z 92 peak will be high. And this is called base peak. So what is base peak? So many peaks you are getting in the mass spectrum. So the peak with more intensity is called base peak. Out of all the peaks, which one is having more intensive? Most intensive peak in the mass spectrum is called base peak. So therefore, here in the case of propyl benzene, the M by Z 92 peak is the base peak. That means it is having most intensity because it is stabilized by resonance. So now one more example. This also undergoes McLafferty. Not only carbons, it may be having oxygens, nitrogen, sulfur, or anything. So this is alpha, this is beta, this is gamma. This is also having gamma hydrogen. So this is called acetonylide. So aniline on acetylation, it gives acetonylide. And this is also having gamma hydrogen. So molecule, you are bombarding with 70 electron volts, you are getting molecular ion, and this is alpha, this is beta, this is gamma. So this hydrogen is shifted here, and this double bond is shifted here. This double bond is shifted here. Loss of CH2 double bond, C double bond, O, ketene. This is called ketene. So CH2 double bond, C double bond, O. This CH2 double bond, C double bond, O is called ketene. So from acetonylide, neutral species loss is ketene. And here double bond is not there, but here there should be double bond, this H and H. So M by Z is 93. 93 peak is due to McLafferty rearrangement. Acetonylide, this is called acetonylide. Aniline on acetylation gives acetonylide. So acetonylide is also having gamma hydrogen. So therefore, you are doing electron impact of 70 electron volts. It is giving molecular ion. So gamma hydrogen is shifted here. This pi bond is shifted here, and alpha beta. This is the alpha beta bond is cleaved. So what is last here? CH2 double bond, C double bond, O, ketene is last, and you are getting the this peak M by Z 93. And this is called ethyl phenyl ether, phenol. This is called phenol. This is ethyl group, this is phenyl group, this is ether. ROR is ether. Here it is AROR. AROR is ether. So phenol, ethoxybenzene. This is also called as ethoxybenzene, or this is also called as ethyl phenyl ether, or this is also called as phenol. Molecular weight is 122. And alpha, beta, gamma. With carbon say end akkarledu. Oxygen anna indachchu, nitrogen anna indachchu, sulfur anna indachchu, edanna undachchu. So this is alpha, this is beta, this is gamma. Gamma hydrogen undi kabatti McLafferty rearrangement avutundi. Electron impact of 70 electron volts, and H dot is migrated to here, and this pi bond is migrated to here, and this is lost. What is the neutral species last? CH2 double bond, CH2. Ethylene is last. And we are getting this M by Z is 94. This is M by Z is 94. So this is McLafferty rearrangement. So now you tell me what is McLafferty rearrangement? The molecule with under electron impact, elimination of a neutral molecule from suitable unsaturated system through a 6-member transition state involving gamma hydrogen transfer is called McLafferty rearrangement. The molecule should contain suitable unsaturated system and gamma hydrogen. Gamma hydrogen is transferred, neutral molecule is last, and rearrangement is taking place. That is called McLafferty rearrangement. So once again, I'll repeat, under an electron impact, elimination of a neutral molecule from a suitable unsaturated system through a 6-member transition state involving gamma hydrogen transfer is called McLafferty rearrangement. So in what type of molecules this McLafferty rearrangement is possible? So alkenes it is possible, aldehydes it is possible, ketones it is possible, carboxylic acids it is possible, esters it is possible, amides it is possible. And if one compound is having gamma hydrogen and the other one is not having gamma hydrogen, means we can differentiate these two compounds by mass spectrum. The first one will have strong peaks due to McLafferty rearrangement, and the other one will not have peaks due to McLafferty. And propyl benzene, we are having gamma hydrogen. This is alpha, beta, gamma. So this will undergo McLafferty rearrangement. So electron impact of 70 electron volts. This is the molecular ion or parent ion. So this gamma hydrogen is transferred to here. This pi bond is shifted here, and this is shifted here. So ethylene is last. CH2 double bond, CH2 is last. This is not ethyl. Sorry. Ethylene is last and neutral molecule, and double bond is shifted here. HH. M by Z is 92. And beta cleavage means here. This is alpha bond. This is beta bond. Beta cleavage means ethyl radical is last, CH3, CH2 dot, and you will be getting benzyl carbocation. Therefore, beta cleavage is also called as benzylic cleavage. And alpha cleavage means this bond gets cleaved. So propyl radical is last, CH3, CH2, CH2 dot. Propyl radical is last, you are getting phenyl carbocation. So therefore, alpha cleavage results in the formation of phenyl carbocation. Therefore, it is called as phenylic cleavage. And beta cleavage results in the formation of benzyl carbocation. Therefore, it is called benzylic cleavage. And gamma hydrogen transfer, loss of neutral species, it is giving rise to the species. Therefore, it is called as McLafferty rearrangement. So McLafferty rearrangement means it is not necessary that it should have only carbons. So it may have nitrogens, oxygens, or sulfur, anything. So this is the acetone, right? This is alpha, this is beta, this is gamma. Electron impact of 70 electron moles. This is the molecular 135. M by Z is 135. And this H dot is migrated to here. And this shifted here, this shifted here. And loss of CH2 double bond, C double bond, O ketene is taking place. And M by Z 93 you are getting due to McLafferty rearrangement. And this is ethyl phenyl ether. This is also called as phenetol. Phenetol or ethoxybenzene also. You can call it as ethoxybenzene. And electron impact of 70 electron volts, you are getting the molecular ion. And this H dot is migrated here, and this pi bond is shifted here, and this CH2 double bond CH2 ethylene is last. This is called McLafferty rearrangement. This is one of the important rearrangement in mass spectrum. They will ask you. And now second one is retro-Diels-Alder reaction. So what is retro-Diels-Alder reaction means? What is Diels-Alder reaction? Diels-Alder reaction means one diene plus one dienophile. Okay, diene ante 4pi electron system, 1,3-butadiene, for example. 4pi electron system plus 2pi electron system. 4pi electron system is called diene, 2pi electron system is called dienophile. So one diene, one dienophile combine together to form cyclic adduct. That is called Diels-Alder reaction. And what is retro-Diels-Alder reaction means? Opposite of Diels-Alder reaction is called retro-Diels-Alder reaction. Here diene and dienophile is giving rise to cyclic adduct. That is called Diels-Alder reaction. Here cyclic adduct is giving rise to 1 mole of diene, 1 mole of dienophile. This is called retro-Diels-Alder reaction. Retrosynthesis already you might have studied. So cyclic adduct is giving rise to diene and dienophile. This is opposite of Diels-Alder reaction. This is called RDA fragmentation, retro-Diels-Alder fragmentation. So it is opposite of Diels-Alder reaction. It is characteristic of cyclic unsaturated compounds. 2 sigma bonds are broken and 2 new pi bonds are formed. 2 fragments are formed, diene and dienophile. So it is opposite of Diels-Alder reaction. And it is characteristic of cyclic unsaturated compounds. Only cyclic compounds are cis olefins. Cis olefins also undergo retro-Diels-Alder fragmentation. Opposite of Diels-Alder reaction, characteristic of cyclic unsaturated compounds, and 2 sigma bonds are broken and 2 new pi bonds are formed. 2 fragments are formed, diene and dienophile. So here, diene and dienophile is giving rise to cyclic adduct. And retro-Diels-Alder fragmentation, cyclic adduct is giving rise to diene and dienophile. RDA can be seen in aromatic ring. So see this, aromatic compounds also undergo RDA fragmentation. So this is what is called, this is 1, 2, 3, 4. Tetrahydro naphthalene. This is tetrahydronaphthalene. Electron impact of 70 electron volts. You are getting molecular ion. So you take this as, forget about this, right? You take this as cyclohexene. Cyclohexene. So this undergoes here, this cleavage of this bond. Cleavage of this bond here. And this bond is shifted here. And this bond is shifted here. This is shifted here. Ethylene is last. Ethylene is last, and double bond here, and ethylene. So it is called, this is called diene and this is called dienophile. So ఒకసారేమో diene కి charge పెట్టండి. This is diene plus dot. ఇది న్యూట్రల్. అండ్ ఇంకోసారి ఏమో డైనోఫైల్ కి ఛార్జ్ పెట్టండి. బట్ డైన్ మీద ఛార్జ్ ఉంటేనే మేజర్ ఫీల్డ్, డైనోఫైల్ మీద ఛార్జ్ ఉంటే దేని మీద అయితే ప్లస్ డాట్ పెట్టారో దానికే ఎంబైజెడ్ రాస్తారు. ప్లస్ డాట్ పెట్టడానికి ఎంబైజెడ్ రాయరు, ఎందుకంటే ఛార్జ్ ఉన్నది కాబట్టి. సో దిస్ ఇస్ కాల్డ్ ఆర్డిఏ ఫ్రాగ్మెంటేషన్. ఆర్డిఏ ఫ్రాగ్మెంటేషన్ ఇస్ నథింగ్ బట్ దీనికి కూడా ఒక సైక్లిక్ సిస్టమ్ అన్నా ఉండాలి, లేకపోతే ఓలిఫినిక్ సిస్టమ్ అన్నా ఉండాలి, డబుల్ బాండ్ అన్నా ఉండాలి. సో సైక్లిక్ సిస్టమ్ ఉన్న cyclohexenes, unsaturated cyclic compounds will undergo retro-Diels-Alder fragmentation. What is retro-Diels-Alder fragmentation means? It is opposite of Diels-Alder reaction, and it gives 1 mole of diene, 1 mole of dienophile. And characteristic of cyclic unsaturated, ఇది గుర్తుపెట్టుకోండి, cyclic unsaturated compounds are olefins, cis olefins, not trans. Cis olefins will undergo Diels-Alder reaction, retro-Diels-Alder reaction. 2 sigma bonds are broken and 2 new pi bonds are formed. 2 fragments are formed, diene and dienophile. This one, first you see this. This one. So here ఈ బాండ్ ఇట్ షిఫ్ట్ అవుతుంది, ఈ పై బాండ్ ఇట్ షిఫ్ట్ అవుతుంది, ఇది బ్రోక్ అవుతుంది, అప్పుడు ఇది ఇథిలీన్ అవుతుంది, ఇది బ్యూటాడైన్ అవుతుంది. సో 1 diene, 1 dienophile. RDA is also seen in aromatic compounds. So tetrahydronaphthalene, molecular weight is 132, electron impact of 70 electron volts. You are getting molecular ion. Molecular ion ఎప్పుడైనా సరే, tomorrow I will take that PDF because it is not there. So tomorrow I get that. This is plus dot. Molecular ion always you are putting as plus dot. And RDA fragmentation. ఇక్కడ ఈ బాండ్ క్లియర్ అవుతుంది, 2 sigma bonds are broken, అంటే ఈ సిగ్మా బాండ్ బ్రేక్ అయితే ఈ సిగ్మా బాండ్ బ్రేక్ అవుతుంది. 2 new pi bonds are formed, అంటే ఈ సిగ్మా బాండ్ బ్రేక్ అయితే ఇక్కడ పై బాండ్ ఫామ్ అవుతుంది, ఈ పై బాండ్ షిఫ్ట్ అయ్యి ఇక్కడ ఒక పై బాండ్ ఫామ్ అవుతుంది, ఈ 2 సిగ్మా బాండ్స్ బ్రేక్ అవుతాయి, ఇదొకటి ఇదొకటి. సో అప్పుడు ఏమవుతుంది, CH2 డబుల్ బాండ్ CH2, ఇక్కడ 2 new pi bonds are formed. దిస్ ఇస్ డైన్, దిస్ ఇస్ డైనోఫైల్. ఒకసారి ఏమో డైన్ మీద ఛార్జ్ పెట్టాలి ప్లస్ డాట్, ఇంకోసారి ఏమో డైనోఫైల్ మీద ప్లస్ ఛార్జ్ పెట్టాలి ప్లస్ డాట్. కానీ ప్లస్ డాట్ ఆన్ ది డైన్ ఈస్ మోర్ స్టేబుల్. So here RDA also occurs in heterocyclic compounds. Tetraatom ఉన్న compounds లో కూడా అవుతాయి. It is called benzopyran. This is called benzopyran. ఇక్కడ కూడా ఒక డబుల్ బాండ్ ఉంటుంది, benzopyran. Molecular weight is 134. Electron impact of 70 electron volts. We are getting the molecular ion. ఇక్కడ ఒక డబుల్ బాండ్ పెట్టండి. ఇది somebody's notes I have taken because I have to take tomorrow. I'll take that PDF and I'll give that notes. So M plus dot or P plus dot 134. RDA fragmentation. This is ఈ బాండ్ బ్రేక్ అవుతుంది, ఈ బాండ్ బ్రేక్ అవుతుంది, ఈ పై బాండ్ ఇట్ షిఫ్ట్ అవుతుంది, ఇది బ్రేక్ అవుతుంది, అప్పుడు ఇథిలీన్ పోతుంది, ఇక్కడ ఓ ఉంటుంది, డబుల్ బాండ్ ఓ, ఇక్కడ అట్లా ఇక్కడ ఓ పెట్టలేదు, ఓ పెట్టాలి. సో ఇథిలీన్ ఇస్ లాస్ట్. ఒకసారి ఏమో డైన్ మీద ప్లస్ డాట్ పెడతారు, ఒకసారి డైనోఫైల్ మీద ప్లస్ డాట్ పెడతారు. దిస్ ఇస్ కాల్డ్ retro-Diels-Alder fragmentation. సో దీంట్లో కూడా పోతుంది RDA fragmentation. ఇది డబుల్ బాండ్, ఈ బాండ్ ఇక్కడ బ్రేక్ అయ్యి ఇట్లా వస్తుంది, ఈ బాండ్ ఇట్లా వస్తుంది, ఇది ఈ సిగ్మా బాండ్ ఇట్లా బ్రేక్ అవుతుంది. సో అప్పుడు ఏమవుతుందంటే cyclopentadiene cation. And this one CH3 CH double one CH2 is lost as neutrons. ఒకసారి దీని మీద చార్జ్ పెడతారు, ఒకసారి దీని మీద చార్జ్. This is called RDA fragmentation. So now you tell me what is McLaughlin rearrangement. McLaughlin rearrangement ఏమేం కావాలి? Suitable unsaturated system, presence of gamma hydrogen, McLaughlin. And retro-Diels-Alder ki, it is opposite of Diels-Alder reaction. A suitable cyclic unsaturated system or cis olefins are required. And here two sigma bonds are broken, 2 new pi bonds are formed. And the cyclic adduct is giving rise to diene and dienophile. One time diene is charged, one time dienophile is charged. Even heteroaromatic compounds also undergo retrodensile fragmentation. So all the examples you go through practice. If you practice, then only you'll be getting. And if you have any doubts tomorrow also you can ask. And I'll give another note. So this is not continuous. It is not in continuous. I have taken from one of my students. So it is not improper. I'll give tomorrow notes. Ortho effect. The third one is ortho effect. Ortho effect is given by ortho disubstituted benzenes or cis olefins. Ortho effect means benzene మీద రెండు substituents ఆర్థో పొజిషన్ లో ఉండాలి. ఇట్లా 1-2 పొజిషన్స్ లో 2 substituents ఉంటేనే ఆర్థో ఎలిమినేషన్ అవుతుంది, ఆర్థో ఎఫెక్ట్ వస్తుంది. So elimination of a neutral molecule under an electron impact from a suitable 1,2 disubstituted benzene or cis olefins through a 6-member transition state. Elimination of a neutral molecule E or OE dot under an electron impact from a suitable 1,2 disubstituted benzene or cis olefins through a 6-member transition state is called ortho effect. Ortho effect ఎక్కడ అవుతుందంటే బెంజిన్ మీద 1,2 disubstituted ఉండాలి, 1-2 పొజిషన్స్ లో ఉంటేనే అవుతుంది. సో ఇక్కడ కూడా డబుల్ బాండ్ ఉండాలి, డబుల్ బాండ్ తీసేసాయి. You put one double bond here. So what is this? This is COOH. This is OH, not OOH. It is something wrong. This is salicylic acid. This is OH. Here you remove the O. This is OH, COOH. That's why you don't take this. Tomorrow I will give another notes. So salicylic acid. This is called salicylic acid. Electron impact of 70 electron moles. ఇక్కడ ఏమవుతుందంటే ఇక్కడ ఓకి హెచ్ కి బాండ్ క్లియర్ అవుతుంది, ఇక్కడికి అవుతుంది. తర్వాత ఇక్కడ డబుల్ పై బాండ్ ఉంటుంది, ఆ పై బాండ్ ఇక్కడ షిఫ్ట్ అవుతుంది, ఇది పోతుంది. అంటే ఇక్కడ ఓహెచ్ పోతుంది, ఇక్కడ హెచ్ పోతుంది, లాస్ ఆఫ్ H2O పోయి ఇక్కడ ఏమవుతుందంటే ఈ డబుల్ బాండ్ ఇక్కడ షిఫ్ట్ అవుతుంది, సి డబుల్ బాండ్ ఓ, ఇక్కడ డబుల్ బాండ్, ఇక్కడ డబుల్ బాండ్ ఓ వస్తుంది, ఇక్కడ డబుల్ బాండ్ వస్తుంది, ఇక్కడ డబుల్ బాండ్ వస్తుంది, డబుల్ బాండ్ సి డబుల్ బాండ్ ఓ ప్లస్ H2O. న్యూట్రల్ స్పీషియస్ లాస్ట్ ఇస్ H2O. So what is ortho effect? Ortho effect is nothing but it is given by ortho disubstituted benzenes and cis olefins. Cis olefins also undergo ortho effect. So elimination of a neutral molecule E or OE dot under an electron impact from a suitable 1,2 disubstituted benzene or cis olefins to a 6-member transition state is called ortho effect. So it is called salicylic acid. This is not again when you rub off this O. Orthohydroxybenzoic acid is called salicylic acid. This is called salicylic acid. So electron impact of 70 electron moles. And here this bond OH dot is last, here H dot is last. Overall H2O is last. And this is methyl salicylate. This is salicylic acid, this is ester. Instead of OH you are having OCH3. So methanol is last. Here this H dot is last, this OCH3 is last. Overall methanol is last. And this bond is shifted here, this bond is shifted here. So double bond C double bond O, here double bond, loss of methanol. This is called ortho effect. కోటేశ్వరరావు ఉన్నావా నువ్వు? కోటేశ్వరరావు, హలో హలో కోటేశ్వరరావు. Just I will give. So tomorrow I'll ask McLaughlin and ortho effect retroinsider fragmentation. You practice properly. I'll ask, you have to write. You should tell at least. So what is McLaughlin? What is ortho effect? What is RBF fragmentation? And next, what is mass spectrum? Mass spectrum is nothing but it is a plot of M by Z ratio values of various cationic species versus relative abundance. M is mass of the ion, Z is charge of the ion, and Ra is nothing but relative abundance. Relative abundance is associated with the stabilities of the carbocations. If the formed carbocation is more stable, means peak height will be more. And next, how do you prove the presence of nitrogen in the molecules? A molecule with odd number of nitrogens will always have odd mass. And molecule with 0 or even number of nitrogens will always have even mass. And presence of nitrogen is confirmed by one nitrogen is present means definitely the molecular weight of the compound is odd. So molecular weight odd immediately you are able to say that nitrogen is present in the molecule. And what is this McLaughlin rearrangement means? McLaughlin rearrangement, suitable unsaturated system, gamma, presence of gamma hydrogen, and loss of neutral species giving rise to the fragment ion. And what is RDA fragmentation means? Retro-Diels-Alder fragmentation, and it is opposite of Diels-Alder reaction. 2 sigma bonds are broken and 2 new pi bonds are formed. One is dienophile, one is diene, one is dienophile. ఒకసారి డైన్ మీద చార్జ్ పెడతారు, ఒకసారి డైనోఫైల్ మీద చార్జ్ పెడతారు. తర్వాత what is ortho effect means? Ortho effect is given by orthodisubstituted benzenes. For example, salicylic acid, neutral species by you are getting the doubly bonded structures. So once you give the syllabus of your mass, so that I'll try to cover everything. Okay. So tomorrow I'll take the class at the same 6:30 only. If it is necessary, no problem. I'll take one more day also. I will explain in a proper way, and notes also. Don't take this. Tomorrow I'll give my notes. So don't worry. And if you have any doubts, you can ask also. But whatever I told today, you take this and you take this. You ask Koteshwar sir, you take this and read first. You read, tomorrow I'll ask questions. You must be able to answer. Okay. So today I'll stop. It's already 8 o'clock. So I'll stop the class. And tomorrow at 6:30, I'll again take the class. And fresh notes I'll give. I'll continue. Okay. But whatever you have completed, you come prepared for the tomorrow's class. Telugulo kavalante Telugulo explain chestam, no problem. How many of you are from Telugu? Yes. ఎంతమంది ఉన్నారు తెలుగు వాళ్ళు? తెలుగులో కావాలంటే తెలుగులో ఎక్స్ప్లెయిన్ చేస్తాను. ఇంగ్లీష్ లో ఇట్స్ ఓకే. If it's okay, I'll explain in English. If you have any problem, I'll explain in Telugu. Tell me. Yes. Hello. Hello. Hello.